Hi everyone, solving this Olympiad question. 2t raised to the power of t over 5 equals to 3. And what is going to be the value of t? It is of the best practice to guess what the value of t is likely to be. Of course, we can put it this way and say if t equals to 1. After all, in mathematics, the left hand side, the whole of the left hand side must be equal to the right hand side. So let's see what we're going to have if we insert t there. So in place of t, we're going to put 1 there, then raised to the power of 1 over 5 as it is in the question. And we need to ask ourselves if this is going to be equal to 3 as it is in the question. And 1 raised to the power of 1, that is t1, then multiply by these 2. We have 2 at the numerator there, then 2 divided by 5. The whole of this is going to give me 0.4. And this 0.4 is not equal to 3. So what does this mean? It means that whatever the value of t is going to be, it can never be 1. So let's try again. If the same t is 2, what I'm going to have, say if t equals to 2, we are targeting if this left hand side is going to be equal to this right hand side, that is the whole of this left hand side is going to be equal to 3. Inserting that, we're going to have 2 as usual, then 2 raised to the power of 2 over 5. Is this going to be equal to 3? This 2 raised to the power of 2, that's going to be 4. Then the whole of 4 multiplied by this 2, that is 8. Then the whole of 8 divided by 5. Then 8 divided by 5, that is going to give me 1.6. The whole of the left hand side here is just 1.6. Of course, this is obvious that 1.6 is not equals to 3. So what does that mean? Wherever the value of t I'm going to get at the end of solving this question, it can never be 2. Because when we assume that if t is equal to 2, what we got is 1.6, and which is not equals to 3. We can go further and say, okay, let's assume if t equals to 3, then this left hand side now is going to become, okay, we have 2 into 3 raised by the power of 3 over 5. Is this going to be equal to 3? Until I check. What do I know? This is 3 to the power of 3, that's going to be 27. Then multiply by these 2 times 27 here, that is going to be 54, and the whole of 54 here divided by 5, and that's going to give me 10.8. so the whole of everything here is just 10.8, and of course this is not equal to 3, it's above 3. That is the closest number that is above 3. Then at the same time, 2 is the closest number of t that is just below 3. So what can we imply from this? We can imply that whatever the value of t we're going to get at the end of the day is just going to be in between these 2 and these 3. Of course, the value of t is going to be above 2 and it's not going to be up to 3. So somebody should be expecting something like 2 points, any number here. I'm going to love writing that here. So if I go astray, I can easily know something is wrong. So my answer is going to be between 2 and 3. However, what is the best way of approaching this kind of question? That is to t raised to the power of t over 5 equals to 3. I think it is wise to first of all eliminate the fraction here, that is the denominator, by multiplying both sides by 5. So I'm going to say, okay, multiply by 5 here, then doing the same thing here, multiply by 5. For sure, 5 goes for 5. Then I'm going to have 3 multiplied by 5 here, that's going to be 15. I have 2 t raised by the power of t equals to 15. And the next thing I'm going to do is to eliminate these 2 here so that I can have only t at my left hand side. And by so doing, dividing both sides by 2. Dividing both sides by 2. This go for this. Then 15 over 2, that's going to be 7.5. Then this equation has now turned to t raised by the power of t equals to 7.5. At this point, I'm going to apply natural log to both sides. Therefore, I have ln t raised to the power of t equals to ln 7.5. to my left hand side, I need this rule in logarithm that says if I have log of x to the power of a, it means my a is going to come here. So the same thing as a log of x. Applying the same thing to the left hand side here, I'm going to have t ln t equals to ln 7.5. At this point, what I actually need at my left hand side here is just only t. So I don't need ln t here. So if I can have only t at my left hand side, so whatever that is at the right hand side is just going to be my answer. However, this ln t, what am I going to do in order to eliminate it? I can say dividing both sides by ln t, because it's not going to end up to where I want, because if after all this is gone, I don't have ln t at my left hand side, well, I'm still going to have it at my right hand side. So what am I going to do is just like reinventing the wheel, doing the same thing all over and over. What I'm actually saying is that it's not the best practice at this point. Therefore, at this left hand side, I'm going to need Lambert W function. So Lambert W function states that when I have a format of this nature, x exponential of x, if I apply Lambert W function to this format, that is my Lambert W function here to this format, is going to be resulted into x. Don't forget that is what I have here, and same thing as what I have here. So the wisdom is that what if I can rewrite this my t here, this my variable t here, in this format? Then if I have it in this format, it's going to be easy for me to apply Lambert W function. And for me to do that, that is going to be a certain exponential identity that I'm going to need. This states that if I have an exponential of ln of x, this is just the same thing as x, because the ln and the exponential are going to cancel each other and I'll be left with x. So however, if I can reformat my t in terms of exponential ln x equal to x, of course that's going to be okay. So if I say exponential of ln t is just the same thing as t, so I can rewrite my t in this way. Remember that in mathematics, the left hand side is same thing as the right hand side, and the right hand side is same thing as the left hand side. This my equation can now be written as, of course, it was t ln of t equals to ln 7.5. Instead of rewriting my t here, I'm going to replace my t with this identity. I have exponential of ln t, that stands for my t that is here. Then this ln t is still there having some nice time, so I have ln t still having some nice time there, equals to this ln 7.5. ln 7.5. The next thing I'm going to do, I just want to interchange this position of my exponential ln t and ln t. I want to write ln t first. Okay, ln t, then exponential ln t. Next, ln t is still equal to ln 7.5. Now it's like we have a format here exactly like this. Remember xx, which is exact format that we have here. We have ln t here, then we also have ln t here, which means I can now apply my Lambert W function certainly without any problem. Note that when we have x exponential of x, apply Lambert W function give us x. In the same vein, I'm going to apply Lambert W function to both sides, the left hand side and to the right hand side, but whatever you do to any side of an equation, you have to do it to the other side. I have ln t, then exponential ln of t equals to ln 7.5. Applying Lambert W function to the left hand side here and to the right hand side here. According to this, of course, we're going to have ln t here standing alone equals to Lambert W function of ln 7.5. And the next thing to be eliminated from this left hand side, is this ln, this natural log. I need to cancel that, and it is exponential that's going to do the job for me. So I'm going to apply exponential to both sides of the equation. So I'm going to have exponential of ln t equals to exponential of w function of ln 7.5. Having this in front of my nose, I know that there is a certain exponential derivative. That is, when we have exponential ln x, this is going to result into x. So when I have exponential ln t, definitely is going to result into t. Then I still have exponential w function of ln 7.5. I'm going to start from the inside, checking my calculator. Ln of 7.5 is 2.02683. I now have t equals to exponential of w function of 2.02683. So by punching my calculator, I'm still going to find the w function of this value, 2.02683, which is approximately 0.858750. Okay, I have t equals to exponential of 0.858750. At the end of the day, the t is approximately 2.360127, which is the exponential of 0.858750, which is the final answer. Remember, from the beginning, we have speculated what actually the value of t is likely to be from the beginning. That is when we said, okay, wherever t is going to be, it's going to be in between 2 and 3. That is going to be above 2, and it's not going to be up to 3. And exactly that is the way it is as it was suggested. 2.360127 is t in between 2 and 3. T equals to 2.360,127.